Today we're going to explore a kind of function that grows very fast. We can illustrate this with just a sheet of paper. We're going to fold this sheet of paper repeatedly into 3 equal parts. When we have made 0 folds, there is 1 rectangle. When we fold the paper into thirds, we have 3 times 1 or 3 rectangles formed. When we fold this paper again into thirds, we can see 3 times 3 or 9 rectangles. Fold into thirds one more time, and we can see 3 times 9 equals 27 rectangles formed. We can make a T-chart of our paper folding demonstration to see what kind of function we've produced. At fold stage 0, we have 1 rectangle. At fold stage 1, we have 3 rectangles. At fold stage 2, we have 9 rectangles. At fold stage 3, we have 27 rectangles. What pattern do we see in these numbers? How does the number of rectangles change as the fold stage increases? Let's add a column to our table to find the pattern. With fold stage 1, we formed 3 rectangles. 3 equals 3 times 1 equals 3 to the first power. With fold stage 2, we formed 9 rectangles. 9 equals 3 times 3 equals 3 to the second power. With fold stage 3, we formed 27 rectangles. 27 equals 3 times 9 equals 3 to the third power. And following this pattern with fold stage 0, we had 1 rectangle. 1 equals 3 to the 0 power. We could continue this pattern indefinitely. With fold stage 4, we would have 81 rectangles. 81 equals 3 times 27 equals 3 to the 4th power. We can see a general rule. For any fold stage x, we have 3 to the x rectangles formed on the paper. This is called an exponential function because the independent variable x is the power or exponent in the function. Let's use a calculator to determine the number of rectangles produced on the paper at fold stage 10. X is 10, so 3 to the 10th would be 59,049 rectangles produced on the paper. We had 6,561 rectangles on the paper. We could use a calculator to guess the fold stage. We know it's less than 10, so let's try 7. 3 to the 7th equals 2,187. Let's try 8. 3 to the 8th power. So at the 8th fold stage, we would have 6,561 rectangles on the paper. Let's graph our fast-growing exponential function. We'll start with our first 4 points. 0, 1, 1, 3, 2, 9, and 3, 27. Let's connect these points with our function. Y equals 3 to the x power. You can see that this function grows very, very quickly as the x values go to the right. It appears to be approaching 0 as the x values go to the left. What if we plugged -1 for x? 3 to the -1 power is 1/3. Similarly, if we plug -2, 3 to the -2 power is 1/9. The function approaches 0 as the x values go to the left, but it will never actually reach y equals 0. In summary, we have modeled an exponential function and used paper folding it repeatedly to show how quickly the exponential function grows.